All right, questions on lab work 6 or review? What about it? Question, which one? Well, we have one more topic to talk about. No more topics? There will be one more. So which question on the review? The graphs one? What?
Actually, the piecewise function, I'm still really lost on it. Even though my roommate tried to help me, I still don't understand it. Honestly, I'm just lost in general.
So one of the things that I talked about, well, we should probably do a piecewise function. Let's see what questions.
I'm going to try not to shut down today.
Did you find out? No? Okay. No problem. Is it mostly graphing the piecewise function or like just questions on piecewise function in general?
Just the concept. Like, honestly, it's really a little mix of everything.
Okay. And you're looking at the PDF, by the way? Okay.
I took the practice test like 3 times already.
Question 1 on the review.
The piecewise function? So I would tell you that if you didn't do any studying between the review, taking the quiz, then it's not worth taking it. And I'm guessing that's exactly what you did. You took it and you took it and you took it and you try and just get 100%. That's not going to help you get anywhere. So my suggestion in day 1 was, or whenever I said this to you guys, is to take it, see what's wrong, print out the PDF, and make sure the questions are right, and mark off the ones that you got wrong. And say, okay.
I kind of been doing something like that. Like, I took the first time around to see what I knew, and I flagged the ones that I did not know.
Mm-hmm.
And then I tried to like go back in my notes, or I was trying to go into Pearson and look on Pearson.
Mm-hmm.
It won't let me go back into like the previous lessons from.
Which you could ask, because I would tell you, yes, there is a way. And the way is that when you're in Pearson, you go to the gradebook. When you go to the gradebook, you go to that assignment and hit review. And you'll get into the assignment, and it will show you a message that says, hey, just so you know, you can do all the problems you want, but it's not going to change your grade. So you can actually do that.
Yeah, so I was trying to do that, and looking at your tutorials.
Okay.
All the yesterday. And the day before.
So you're taking it once every day then?
I'm trying to.
Okay. So again, I would tell you that if you don't get enough practice in, like let's say that I got, let's just say that I got every other one wrong, right? So out of 25, so that means about 12, 13 one of them wrong, okay? So I would look up for 12 or 13 of those different problems and say, or heck, I can just take the review and just take a picture with ChatGPT and say, give me a similar problem and work it out. Go through the notes, work it out. Is this the right answer?
Sometimes they find that they skip steps, so then I have to go back and do it.
Absolutely. Absolutely. But I'm just saying, give me a similar problem, right? Which is exactly what Pearson would have as well, right? Because you hit similar problem. So I would practice that, practice that. I got it? Cool. Let me go through all 12 of them that way. Then I might retake the quiz. And then go, okay, how did I do? So let's say now I only got 8 wrong. Okay, let me look at those 8. How many are repeats? You know what I'm saying? How many are repeats of what I got wrong before? So clearly I need more practice on those. right? I want to practice, 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 and then retake. You know what I'm saying? All right, so this is a stepwise function, or a piecewise function. So it says find g of 7. What does a 7 stand for? The x value, right? Because we usually write it as g of x, f of x, right? So whatever's inside the parentheses is my x value. So the 7 is my x value. I'm looking for the y value, right? So g of 7 means, if it tells you to find g of 7, it means find the y value when the x value is 7. Okay? So the question is, which equation would I use if the x is equal to 7? So I look at my domain restrictions. Is 7 equal to 3 or not equal to 3? So that's the equation I would use. Does that make sense? So again, 7 is my x value. Is 7 not equal to 3, or is 7 equal to 3? It is equal to 3? Okay. So it's not this. So therefore, I would not use that. I would have to use that.
You just plug 7 in.
Bingo. So that means this is going to equal to there we go. Is that the answer? No graphing necessary here. If it tells you to find a point, then there's no graphing needed. If it doesn't say this, then you have the graph. So if I was to graph this, let's say I was to graph this, okay? This would be a lot harder to graph because of the fraction. You know what? Let's make it simple. Let's do it this way. Let's add the graph like this. Is that fair? Okay. So I have two functions here. Here I see y equals x minus 3. What kind of graph is that? What do you mean by linear? A diagonal line, right? Because x to the first degree, y to the first degree crosses the x-axis once, crosses the y-axis once, diagonal. How many points do I need? 2 points. Awesome. The next one over here This says y is equal to x plus 6. Also diagonal line, only need 2 points. Fair? Okay. So I do the first one. Here's my x. Y equals x minus 3. It says x cannot equal to 3, but 3 is what's shared, right? It's in common. So I need to use 3. Give me another point. Does it make sense to what I just did? Does it make sense that I picked 3 and picked 2?
I'm just kind of confused as to how do you know how many points you're trying to find for? Because you said that you need 2 points. So.
Okay. If I plot 2 points and I was to draw something, what would that create? A line, right? That would look something like that. Agreed? So whenever I have a straight line or diagonal line, I just need 2 points, right? Because if I was to only give you 1 point, can you draw a line? No. Well, you could, but you have no idea what it looks like, right? It would just spin out of control. That's why I would need 2 points. Why would I need 3 points? But what I'm saying, why would I need 3 points? Is that going to give me a straight line? Try again. Look at it. That'll give me a curved line, right? So if the line is curved, I need 3 points. Because I need to know how it curves. 2 points, I can't draw a curved line. Does that make sense? That's why I need 2 or 3 points. Fair enough? Okay? So that's why I have to look at these two equations saying, are they? What kind of graph is it? They're both diagonal lines. So I know that both of them I need 2 points, right? This is going to kind of put a kink in that because it only allows me 1 point. See what I'm saying? It only allows me 1 point. So once I have this, three, 0. Oh. And at 3, is it open circle or closed circle? Closed circle? For the red? Because I'm doing the red, right? Yeah. Is it open circle or closed circle? At 3, 0.
Is it open because it doesn't equal?
Correct. Beautiful. Okay, so at 3, 0, it's going to be open circle. Oh, that's not open circle. There we go. And then I got 2, -1. So I have a line that goes, actually. Uh-oh. I guess I can just do this. That's all right. And then the blue, I want 2 points, but it doesn't allow me to. It's telling me x is only equal to 3. So I can only use 3. And that's going to give me 9. And is that open circle or closed circle? So 3, 9. Oh boy. 2, 4, 6, 8, 9. So there's my graph. Not too bad. But not too bad, right? So now we understand why it's 2 points, why it needs 3 points, and so on, right? Versus, it's never just 1 point. This one handcuffed me to only 1 point. But typically I need 2 or 3. Where's your hand raised?
I was wondering if like this was on the review.
Yes, number 1.
Oh, okay.
Except not this one, the previous one, yes. Any other questions?
Like on this or like in general? Question 9.
On the review?
Yeah.
I think G of X. Like on the domain.
That's not what number 9 is.
Oh wait, I'm sorry.
It's okay. It's okay. So number 9 says y equals negative square root of x minus 8, and it's wanting to know if this is a function. So if we need to know if an equation is a function or not, what's the first thing we got to do? What did our notes say?
You know what?
The notes would say solve for y. Is the y by itself already?
Yeah.
Oh, okay, cool.
So
No work even needed. So now what do we need to figure out?
Does every input have one output?
So does every x give me only one and only one y value? So let's pick an x value. Or let's go 9, because 0, if we get positive, negative, 0, it's still 0, right? So let's try 9.
it can't be a negative in there.
Correct, it can't be a negative in there. But that doesn't make it not a function, right? If we put 9 in there, 9 minus 8 is 1. Square root of 1 is, but do I have a positive and a negative 1? Just a negative 1. So I only got one answer.
So you're just plugging in numbers. So that X value.
Correct. So when is this the only time that's not going to be a function? So be careful. Only time that this is not a function is if this says plus and minus.
Like visually it shows you plus or minus.
If it's just a square root.
No. It literally has to show you that, or the way I did it in the notes. I make you solve for y, and you had to do the square root property, which you got to add the plus and minus. Okay? When there's no subtraction sign in here, it's already telling you I want only the positive side. This is just telling you I only want the negative side. Does that make sense? So when there's no sign in front, it's telling you I want the positive side. So if it's a plus and minus showing, then it's not a function, because every x gives you a y. But if you forget that, you can just plug a bunch of x in here, just to guess, right? And see if any of those values get you 2 y values. But if each x only gives you 1 y value, then it is a function. Make sense? Okay? So if you look back in the notes of this, I did it where I said that I put the y on the other side, and the y was squared. And you had to get y by itself, so you had to take the square root of both sides. And that caused you to put in the plus and minus, because every time you take the square root, you got to have the plus and minus. That puts a plus and minus in there. Then you go, uh-oh, it's not a function. Okay? Is that fair? And what was your question again? Was that composite or multiplying?
Oh, I'm sorry.
I think it was.
Used in general, honestly, because like if you have to simplify. Honestly, I don't know.
What do you mean by simplify?
Like I was watching like a YouTube video yesterday on like finding the domain of a composite function.
Okay.
And I was honestly
Okay. So But here's the thing. You don't need to know. Okay, so you just need to know how to find a domain, period. Finding the domain of a composite function has nothing to do. Well, I shouldn't say that. I should say this. Finding a composite function is finding a composite function. Find the domain is find the domain. Don't intertwine those two together. Does that make sense? Do the composite, finish the composite, now find the domain. Don't try to find the domain as you're doing the composite. Okay? You know what? I'm going to mix number 7 in here, but I want to make it a composite. So let's say that, because this would be fun. Okay, this is not going to be fun. This is going to be interesting. I'll say it that way. I'll make it not as interesting as I put in my head, okay? So let's say I want you to find G composite F of X. How do I find that? So is that what you guys are solving? Which one? Be careful. This is telling you that. Nope, composite. Look at the order. This is telling you the order. This is telling you the order. Like that. That's what it's telling you. It's telling you the order. Okay? Because you're replacing the x with 2x over x minus 9. Okay? So let's say now it asks me for the domain of this. Notice that I'm only worried about composite on the composite. Now let's say it wants the domain. Are you freaked out?
Yes.
Why? Because it looks weird?
It's giving me dyscalculia.
Huh?
It's giving me dyscalculia.
Okay. So tell me, what are 2 things we're concerned about when we're looking for domain? Fraction, denominator can equal to 0. What's the second? Starts with square, ends with root. The square root, the radicand has to be greater than or equal to 0. Unless it's the denominator, then it has to be greater than 0, not equal to 0. Those are all in your notes as well. Okay? So, over here, do we have any radicals? Do we have any square roots? No. We only have a bunch of fractions. Is that right? How many denominators do I have? Because that's what I'm concerned of with fractions, right? I'm concerned with denominators can't equal to 0. How many denominators do I have? 2. Give me the first one. Okay, so this is the denominator right here, right? Let's try and make that an oval instead. There we go. All right, so you're saying that the denominator, x minus 9, cannot equal to 0, yeah? Okay, so x cannot equal to 9. Awesome. There's one part of my domain done. Does that make sense? Do we need to know anything more to see that? No, right? Because we see that fraction. We see that denominator, right? Okay. What other denominator do you see? Oh, we got more than that, dude. Isn't this whole thing right here a denominator? Yeah. Now, is the math going to be easy? Maybe not. But what we do know is this, right? We know that 2x over x minus 9 plus 4 also cannot equal to 0. This is the part that gets hard, right? Doing the math on this part, it gets hard. Yes? Yes? Did I do anything wrong?
No, I'm sure you did it right.
I have no idea. That's why I want you guys to run through it. So here I got a single fraction and a single fraction, so I can multiply both sides by x minus 9. That's why I got this. Okay, so when I multiply this by x minus 9 cancels out. Multiply this side by x minus 9, I got that. Distribute. Get the x on the same side. Divide off the 6. Okay? Do I have any other denominators? Okay. So you're telling me that I have x not equal to 9, x cannot equal to 6. Great. Six, 9. Open circle. Open circle. So what's my domain? Questions? Yeah. Should we finish our notes for this exam? Yeah? That was the other one? Good thing I'm doing this, huh? Thank goodness you're doing the inverse. Been wondering about that. So f of x will be your given function. And once you find the inverse of that function, it's going to be denoted as f negative 1 of x. So you see the denoting of it is a little bit different, right? The function, f of x. Inverse, f raised to the negative 1 of x. Step 1, replace f of x with y. Is anybody confused on the first step? We understand replacing f of x with y. This is like the opposite of function notation, isn't it? Because you guys know what function notation is, right? We replace the y with f of x, right? So now we're here, we're replacing f of x with y. Step 2. We're switching x and y. Okay. Go ahead and do step 3. Solve for y. Some of you guys have. Never mind. That's part of finding inverse. I'll explain why soon enough. But that is part of finding inverse. I'm glad you asked, though. So these two both mean the same thing, right? This is more of a y equals mx plus b form versus that. You guys ready for step 4? Another hard step. Very hard step. Another very hard step. Hope I didn't lose anybody there. Did I hurt anybody's feelings? Yeah, sorry. Sorry, brain is full. We okay? Not okay? What part?
Just maybe I'll catch on if you explain.
Is it solving for y?
Yeah.
So how did I go from here to here? Okay. So if I was to get y by itself from here, right? I got to get y by itself. So I got to subtract 3 from both sides, yes? So my left side is going to be x minus 3. And my right side is only going to be left with 4x. Then I divide each side by 4. Hence getting that. Right? So now there's 2 ways of doing this. I can either divide this side by 4 and divide this side by 4, and I'll get that. You see where that came from? Okay. Or I can divide each one by 4. Then I would get this result. Then we just replace the y. Mm-hmm. You're probably going to see the top one more than the bottom one. Mm-hmm. Yeah. Yeah. They're both the same things. Are we okay so far? So the question was, why are we switching to x and y? Okay? And I said, well, that is the part of actually finding the inverse function. So what the? Not what I wanted. Well, son of a. Keep on deleting the wrong thing. Okay. So the given function was this. Is that right? That was what we were given, 4x plus 3. When we found the inverse, we found this. Is that right? What do you notice about those 2 lines? Huh? What else? Ooh, they reflect off of each other. They're reflections of each other in what, over what line? Over x axis? The y-axis? It's no axis, but there is a line. So step 2 says switch x and y. Is that right? So what does that really mean? What does switching x and y really mean? It's saying, hey, I want you to let x now become y. I want you to let y now become x. I think I just saw the name of a professor. Okay. So if y is now going to become x, that means now y is going to equal to x. Is that right? And x is going to equal to y. Is that right? Okay? So I'm saying they're equal to each other. So right there, you guys heard two different equations. Is that right? What equation did you just hear? No. What equation did you just hear out of my mouth? Awesome. Let's graph that. Y equals x. Do you guys see your reflection now? Because the inverse is actually a reflection over the line y equals x. Okay? So, we have to find the inverse when we're given an equation by utilizing those 4 steps. So we got to remember that. Fair? Yes?
Will these problems have square roots incorporated in them?
Oh, yes, it would. Okay, we'll talk about those. Don't worry. Okay? Because what's the opposite operation of a square root? Squared. What's the opposite? Yeah. See, if you were in my 1033, you would already know all that because you would have saw the sun and you would have saw grass and a tree. You would have saw all that. I draw pictures. All right, so you guys agree with that? So we also have to find inverse if we're given a graph. Just like, oh, there's a graph, right? So what I want to do is this. I'm going to go ahead and have the table of this come up and also make the table of this come up, okay? And you see the table of the red, yes? I'm going to change the table of the blue a little bit. Let's make that a -5. And let's make this 3. Let's make this 7. And let's make this 11. What do you notice about the x and y's?
I can't see that far.
Isn't the x became the y value and the y became the x value? So if you look at, this says -2, -5. Down here it says -5, -2. Exactly opposite. Hence, the switching of the x and y again comes right back into play. So that step 2 is such a big step. Now, let's stay with that step. What else do we call x's and y's? We talked about this in part of the Q&A in the beginning of class. What were you asking about?
Domain range.
Domain and range. Aren't those x's and y's? Guess what happens with the inverses? They switch as well. So the domain of the function is now going to be the range of the inverse. The range of the function is now going to be the domain of the inverse. Make sense? So that has so many things that affects of just saying, switch to x and y. Yes?
Are we ever going to just be given a graph from the graph?
Of course. And you're going to be like, oh, shoot. You're going to be like, so how do we do that? Is that your question?
Oh, yeah.
Okay. Let's do this. I got to change this a little bit. Let's do, since you love square roots. All right, so let's call this my f of x. Okay? So if I was given a graph, how am I going to find the inverse of this graph? So you're going to try to tell me what the equation of that line is? I'd be impressed, but. Because what did you tell me about the table? They switch, right? Okay, so what if I pick some points? Can anybody pick some points? Or you mean? Is this starting to look familiar? Doesn't it look like transformations? That we had to get points from the parent function? Oh. Interesting. Okay, so if those are my points, it was -3, 0. That came from f of x. -2, 1. 1, 2. My eyes are awesome. I can't see crap. All right, so can you guys tell me what the inverse function is going to be? Okay, let's plot those. 3, 6, 2, 1. 1, -2, 0, -3. Huh. Does that look like a reflection over the line y equals x? Not at all, right? Nothing at all. Doesn't look pretty whatsoever. It kind of does look pretty, though. It does. It actually does. But do you guys see this? Right? Not the best picture because
It is the reflection.
Yes.
Okay.
Darn chance sarcasm. Just that now it looks better. Everybody see that? So if we're given a graph, that's all we got to do. Just like if we were graphing transformations. Right? We need to get 4 points or as many points as we can from the parent function. If it's 4, if we can get 4, let's get 4. If we can only get 3, we got to only get 3. Okay? And then we switch to x and y's, and we're done. Put on that thing.
Is that it to this lesson or is there more?
Well, it is. It pretty much is all it is to the lesson. I'm going to talk a little bit about a couple other things to look out for. Any questions there? Are we okay? We're good? So here's the other thing, guys, because I believe you said, yeah, I had a question on that, on the lab work, that asked about find the inverse of the one-to-one function. You guys are going to keep on hearing the words one-to-one function. What the heck does that mean? What the heck does it mean by when they say one-to-one function? Someone's replying to that already. Look at that. Ding. So the one-to-one function, what that means is that when you find the inverse, that is a function. So we did the purple line, we did the blue line, so notice that the blue line is now a function. Everybody agree? So if I say that the purple line was a one-to-one function, that means that the inverse, the blue line, is a function. How can you prove that the blue line is a function or the blue graph is a function? It passes the vertical line test. So saying the inverse is a function means that my inverse would pass the vertical line test. Everybody agree? Yes. There is. Because if I took the vertical line and reflected over the line y equals x, what kind of line would that be? Yep. If I took a vertical line, reflected over the wall, switch to x and y, it becomes a horizontal line. So it's okay, because last class we had the same conversation. When I was younger, I didn't know the difference between the two. But that's exactly what a teacher said to me. I go, what's the I can't tell. They're like, have you ever seen the horizon? I go, never mind. Because when you look out in the horizon, it's horizontal. That's why we don't look at the vertizen. Look at the vertizen. What? So here's the thing. If the inverse is a function because it passes the vertical line test, that means the one-to-one function, the original function, the given function, must pass what? It has to pass the horizontal line test. The vertizon. The hertizon. Does that make sense? Right? Because we were just talking about vertical line test, but if we flip that over the line y equals x, which means switch to x and y, we'll get a horizontal line test. Okay? So that means the one-to-one function passes the horizontal line test, which means then your inverse would pass the vertical line test, which means it will be a function. So in order for you to find the inverse, you have to have it to be one-to-one. Okay? Any questions there? Okay, so here's the other warning I wanted to give you. One of your problems is going to do this. And the question is, which functions are the inverse of each other? That's the question. Which function are the inverse of each other? So I'm going to tell you what you're supposed to do, what my video says to do, versus what I'm going to allow you to do. So first of all, if you were to wonder if f and g of x are inverses of each other, what you have to show is that f composite g of x is equal to g composite f of x. That means the composite going forward and the composite going backwards are the same. And if you're wondering, if you're wondering if G and H are inverses of each other, then you will have to do, okay, G composite H of X has to equal to H composite G of X. And the third one would be that F composite H of X will have to equal to H composite F of X. So that's the way you're supposed to do it. You got to do all those composites and see which one equals to each other. You're like, shut the front door. So what would I allow? Yes. So when you guys look at this, I'm bringing this up because in your future classes, they might expect you to do this so that you're not surprised going, oh, yeah, that's right. Chan just mentioned that. What I'm going to allow is this. I'm going to allow you guys to look at, find the inverse of F of X and see, is that equal to G of X or H of X? If not, then let's find the inverse of G of X. And see if that's equal to F of X or H of X. Then I want you to find the inverse of H of X. Oopsies. And see if that's equal to F of X or G of X. And what you're going to find is that these two are going to be the same, so therefore they're inverses of each other. Okie doke? This is a little less work compared to the other one. Trust me. It was confusing, right? That's why I was like, I might as well have you guys practice on finding inverses and then comparing it instead of finding composites.
Could we try to find it, like, I'm kind of confused on how to do, like, the inverse of, like, x minus 8 over 2. Like, how would you do that? Like,
Switch y and x. Just solve that code.
What's step one?
replace f with y.
Okay. Step two.
Switch x and y.
Step three. Okay. And then? Wow, you seem so confused. You seem very confused right now. You just walked me right through the problem. Is the presence of me. Must be. So you got to take this picture out, find a picture of me, and put it right there. This way, when you got a problem, you're like, Chan, I got to talk to you.
Or put it in my calculator.
The back of your calculator is fine. You just pop it up and go, Chan, I got to talk. Yes.
I have a question.
Uh-huh.
The one with the square root.
What about it?
Can we try and solve one, like as an example?
Do we have a problem like that on the review?
It's on Pearson. I don't know if it's on the review though.
Did you happen to write it down?
I did not.
I did not.
I'm sorry.
It's okay. Nothing to be sorry about.
I just like to be prepared.
You could. Let's see. Can you give me a square root equation to find the inverse of? Let's see let's see what it does. Okay, ignore the rest. Write that problem down. Two x plus 5 minus 3. Two x plus 5 minus 3. Ooh, this is actually a harder problem than they made it to be. Step 1. Bless you. Step 2. All right, how do I solve for y? Huh? I talked about this when we were talking about radical equations as well. This was in exam 1. Anytime we have a radical equation or equations with rational exponents, what do we do first? What do we always try to do? Isolate the radical. We want to get the radical by itself. Absolutely. Okay. How do I get rid of the radical? Okay. If I do it to the right side, I have to? Awesome. So what does x plus 3 squared mean? Which means? Multiply by itself, which means? Ta-da! Nice and easy. So easy, so easy, so easy. Is it going to help me simplify it? No. And it's not factorable anyways. Because there's no two numbers multiplied together to give you 4, added together to give you 6. Besides, nothing. Yeah? Well, it's hard. Because it's not. Not at all. All right, I got to give you guys some warnings here. Warning number 1 is this right here. So you're going to see this on the review. You're going to see this on the exam. And just so you guys know, it is not just this line and this line. Okay? It's not just those two lines, guys. There is a line right here and a line right here. Huh? Yes. That's why seeing that those two lines are important. Trust me, people aren't going to see it, especially on the exam, especially when anxiety is high. They're like, not registering, not registering, not registering. I'm done. That was not the question I was thinking that you were going to ask.
What question do you think that's that?
Really? Number 2?
Not gonna lie, yeah.
Okay. What are the 2 things you need in order to write an equation of a line? You need a slope and doesn't have to be y-intercept. A point. I just need 1 point and a slope. Are you given a point?
Yeah.
You're given a point. So point, check, done. Are you given a slope?
Yeah.
What's the slope? No. Oh, it is. Yeah, it is parallel, isn't it?
But if it was perpendicular, it would be what, 2?
Yes. Flip and negate. And then you take the slope and the point.
You replace it after the equation.
You put it in the equation, and you find your line. Does it matter if I use slope-intercept form, y equals mx plus b, or point-slope form? Y minus y1 is equal to m times x minus x1. But here's the thing. The point-slope form, you already know that formula. Do you know where it comes from? So it's called point-slope form. Okay? Point-slope form. Let's extend that. Point-slope formula. What other formulas do you guys know that uses points and slope? No, that's a slope-intercept form. So what other formulas do you know that talks about points and talks about slope? Okay, what's the slope formula? If you cross multiply that, guess what you have? The point slope form. That's why I say it's nothing really hard to remember, because if you know the slope formula, you know the point slope form.
In the equation, it's like, what is it, like 1/2 x, I forgot what it was, of the in there.
Before it equals -1/2 times 5 plus 8.
I did it yesterday and I got it right, and I completely forgot.
Just need to practice more.
You write the equation out.
Which one?
The one I asked you for help on. You talked about it. I didn't finish it.
Did you not just do it?
I didn't know it all looked right.
So where did you go wrong?
I kept the 8 in the equation instead of turning it to b.
So do I want that line? So why would you use the 8? You don't want to be part of that line. You just want something parallel to it. But the problem is that if you want something parallel to it, and you get that same y-intercept, that means you want it to be the same exact line. For what reason? So again, I needed a point. I needed a slope. I didn't say anything about wanting a y-intercept, did I? So why would I take the y-intercept for? Does that make sense? All right? I only need a point and a slope. That's it. That's why I plug in. Notice that nothing else that I plug in besides the point and the slope. Now, there's a reason why I brought this up as well. Here's my question. What if I made those y's a function notation? What would it become? Yeah. How do I make something function notation? How do I make something function notation? What does function notation even mean? I haven't reminded you guys in step 1 of inverse. What did I say? What did I say about inverse? The first, huh? That was the first step in inverse, and what did I say? It's like backwards of the function notation. Because what's function notation? No. Backwards of step 1 to find the inverse. So look at inverse and go backwards. What's backwards of step 1? That is function notation. Replacing the y with f of x. That is function notation. So I want to replace the y with f of x's. So how do I replace y sub 2 with f of x's? Do I just do this? Is that what I do? Would that work? Why do I have this as y sub 2, y sub 1, x sub 2, x sub 1? Okay. So based on these two here, what are the 2 points I have? X sub 1, y sub 1. X sub 2, y sub 2. Does that make sense? Now let's see if that will help me fix this. So you're saying that this y value has to correlate with this x value. So how do I write this to correlate with that x value? And how do I write this to correlate with that x value? Huh? Yes or no? Now it makes sense? Because in order for me to find this y value, I got to plug that x value in there, right? In order for me to find this y value, I got to plug that x value into it. That formula right there is called the average rate of change, which is on the review, which is also on lab work 4A, or was. No, that's it.
I saw a question where it's like,
If you saw it, it's going to look something like, maybe you saw this.
oh, F of A, yeah, where's F of B, yeah.
Same difference.
I thought it was B minus A. Sorry, I just want to make sure I get the formula right.
It's about the order. So if you want A and then B, then the bottom is A and then B. If the top is B, then A, then the bottom is B, then A. So what's the difference between a slope and an average rate of change? Well, the average rate of change equations, they're going to give you the x value. They're going to give you two x values. Okay? They're not going to give you y value, but they're going to give you a formula for f of x. So you got to take the x value, plug it into the formula, and say, oh, there's my y. You take the other x, plug it into the formula, and go, oh, there's my y. Now you have 2 points. So again, you can find the slope. This is just finding slope. So the average rate of change is just slope. Just like the difference quotient is just slope. Difference quotient is f of x plus h minus f of x all over h. That is the difference quotient. All right. Any other questions? Okie dokie. Ladies and gentlemen, please have a wonderful, blessed weekend. Please be safe. Love you guys. See you guys next Tuesday. Later.